Hello everyone. So let us continue our discussion on impact of jet. So this is part 2. In last class we have seen impact of jet on a stationary plate. So in this session we will be dealing with impact of jet for a moving plate. So as we have seen in the last class, here also moving plate has three divisions or three types. That is force exerted by jet on moving plate when the plate is vertical to a jet. Second one is plate is inclined to a jet, and the plate is curved one. So we will look into each of these cases one by one. So coming to the first case on moving jet, moving plate. So here we are trying to find out the force on flat vertical plate moving in the direction of the jet. So this is the figure. So unlike in the last class, here the plate is not stationary, as you can see from the figure. The plate is having a velocity, is moving with a velocity u, and the jet of water is moving with a velocity v. So you can see here, this is the plate, and it is moving to some other location, say here. So here we have two velocities. One is a capital V, that is velocity of the jet, and u is the velocity of the plate. So as there are two velocities, that is the velocity with which this jet of water strikes the plate is the relative velocity. Why? Because both of this is having velocity, both of this is moving. So the velocity with which the water is striking the jet will be the relative velocity. So in this case both are moving in the same direction, so the velocity with which it is the striking velocity will be v minus u, as you can see in this figure. So let v be the velocity of the jet, that is the absolute velocity, a is the cross-sectional area of the jet, and u is the velocity of the flat plate. And as I have told earlier, the jet does not strike the plate with velocity v. Recall that in last class, that is the stationary plate, there was only one velocity, capital V. But because here plate is not stationary, plate is also moving, therefore it is striking, the jet of water is striking with relative velocity, and relative velocity is equal to the absolute velocity of jet minus the velocity of the plate. That is, the relative velocity will be v minus u. So proceeding in the similar way as in the last class, we will find out the mass of water striking the plate per second. So in the recall that in last class we had, it is mass of water striking per second the plate is rho a into v, but here it is rho into area of the jet into velocity with which the jet strikes the plate, or the striking velocity. So here the striking velocity is v minus u. So m dot, you can write here, m dot is equal to rho a into v minus u. So what is force exerted in the direction of x, that is mass of water striking, into the initial velocity minus the final velocity. So initial velocity is v minus u, and that is the velocity of striking velocity, and the final velocity after striking, as you know, there is no direction in the no direction of the water in the x direction, so final velocity is 0. So you'll get the expression rho into v minus u the whole square. Now in the moving plate case, we are moving a bit forward, and we have to find out the work done, because the work will be done by the jet on the plate. Why? Because the plate is also moving. But in the last class, that is for stationary plate, we didn't find the work done because the work done was 0. But in this case there will be some work done, so we will not stop by finding out the force exerted, but we have to find out the work done, and in some cases we have to find out the power also. So work done, as you know, is force into the distance. You know that work done is F into D, force into distance or displacement. But here again, we are interested in finding out the work done per second by the jet on the plate. Remember that work is done by the jet on the plate. So we are finding work done per second. So work done per second, or W by T, or this also W dot, we can express this like that, will be F into D by T. Okay. So what is this d by t? This is nothing but velocity. So we can write work done per second is equal to force into distance by time, or this is velocity, that is we can write Fx into u. Why you have substituted u? That is work is done by the jet on the plate. So we have to substitute the velocity of the plate. And we have already mentioned that the velocity of the plate is expressed by u. That is why we substitute u and not v. So fx expression we have already got, rho into a into v minus u the whole square into u. So that will give you the expression for work done. Now moving on to the second case, that is force exerted by the inclined plate moving in the direction of the jet. So in this case, the plate is an inclined one, and again both jet and plate are having velocities, or both are moving. See in the figure, the plate is inclined at an angle theta with the axis of the jet, and here again it is striking at a velocity v minus u. So similar terms are expressed here also, v, u, a, and theta is the angle between um, the jet and the plate. So here again we will get the mass of water striking per second as rho into a into v minus u. And in all cases we are assuming that the plate is smooth, so that there is no impact losses, or we can say that jet of water will leave the inclined plate with velocity v minus u itself. There is no losses, or we are neglecting the losses. Now recall that in our stationary plate case also we have found out, in the case of inclined plate we are more interested in finding out Fn, or the normal force, and then we will find the components of those normal forces. So here also, proceeding in similar way, we will find Fn is equal to mass striking per second into initial velocity in the normal direction minus final velocity in the normal direction. So again substituting the values, initial velocity in the normal direction is, as you can see from the previous figure, v minus u into sine theta, and again in normal direction there is a velocity, the water is not moving, or there is no passage of water, so the final velocity is 0. So we'll get the expression rho into a into v minus u the whole square into sine theta. Now Fn can be resolved into two components like we have done in the last case, Fx and Fy. So Fx is Fn sine theta, that is, you can see from the figure. So substituting, you will get this expression, and similarly Fy is Fn cos theta. Refer the figure for better understanding. Rho into a into v minus u the whole square into sine theta cos theta. And again here also work done is Fx into distance per second in the direction of x. So work done, we are finding it in the x direction only, because there is no movement of the plate in the y direction or the perpendicular direction. Plate is being displaced in the x direction only. So we will find out the work done as Fx into distance per second in the direction of x, and finally you will get the expression, and the unit of work done per second will be Newton meter per second. Now coming to the last case, that is here we are dealing with curved plate. So this is the expression, this is the figure showing the curved plate. So here also we are assuming that the plate is smooth, so that there is no loss, so that the water which is striking here with the v minus u will pass through both sides. and is exiting also by the velocity v minus u, and we are finding the component, horizontal component, as v minus u cos theta and v minus u sin theta. So again, here the relative velocity is v minus u, and the plate is smooth, and due to impact, the velocity with which jet will be leaving the curved plane will be v minus u itself. But this velocity can be resolved into two components, and one in the direction of if you draw the coordinates like this, x, and this is y. So in the exit velocity in the direction of the jet travel is this one, v minus u cos theta, or strictly speaking it is minus v minus u cos theta, because it is in the opposite direction, moving in the opposite direction. So that is being written here, component of velocity in the direction of jet, that is minus v minus u cos theta, and component of velocity in the perpendicular direction is this one, v minus u sin theta. So again, substituting the value, mass of water striking the plate is again rho a v minus u, same thing, and force exerted Fx is rho a into v minus u into initial velocity in the direction, so the striking velocity is v minus u, and exiting velocity in the direction of jet is minus of minus v minus u cos theta. So minus minus plus, and finally you will get the expression like this. Similarly, work done will be Fx into u. Substituting the value, you will get the expression like this. So hope you have understood all these three cases. Now we will look at some of the problems coming in this session. So first one is, a jet of water diameter 10 centimeters strikes a flat plate normally with a velocity of 15 meter per second. The plate is moving with velocity 6 meter per second in the direction of the jet and away from the jet. Find the force exerted by the jet on the plate, and second one, work done by the jet on the plate. So here is a flat plate. It's a vertical plate case. You are given the diameter of the jet 10 centimeters, and you are given the velocity of the jet, that is capital V is given, u is also given 6 meter per second. You are asked to find out Fx and work done. So once d is given, you can find the area, vu is given. So substituting from the expression, Fx is equal to rho into v minus u, substituting, you will get the answer 636.17 Newton. Again, work done, you have the expression Fx into u. So once you have already got Fx, you can substitute that value and multiply it by 6. So you'll get the expression value of work done per second as 3817.02 Newton meter per second. So suppose you are asked to find out the power and efficiency of the jet in the previous problem itself. So you have already got the work done, which is equal to 3817.02 Newton meter per second. So what is the power? Power is nothing but it is the same as work done per second. But usually power we express in kilowatt. Therefore, this value you have to just divide by 1000 to get the value of the power in kilowatt. So power of the jet is nothing but work done per second, just divide it by 1000. So that the answer will be 3.817 kilowatt. That is the power. Now, how to find out the efficiency of the jet in the same problem? So as we know, efficiency in generally efficiency is output by input. So here in the case of jet, it is the output of the jet per second by input of the jet per second. So what is output of the jet? Output of the jet is nothing but what you have already got, the work done per second by the jet. It is just the output of the jet is nothing but 3817.02 Newton meter per second. Now what is the input of the jet? So the jet initially, the input of the jet, or the energy that is jet is having initially, is the kinetic energy. So we can say that input per second is kinetic energy of the jet per second. Kinetic energy is half mv square, or since it is per second, it is half m by second into v square. So mass per second, recall you have already find out this value, mass per second, that is rho av. Why only V means in the initially you have only the kinetic energy. You are concerned about the jet only. So you the initial velocity of the jet is only V. So we substitute rho into A into V and not rho A into V minus U, because V minus U is the relative velocity. Here we are concerned only about the kinetic energy of the jet. So mass per second means mass per second of the jet, that is rho into A into V into again V square, so rho half rho A V cube. Substituting, you will get the answer kinetic input energy as this thing. So divide these two, you will get the efficiency 28.8%. Now moving on to the second problem. A 7.5 centimeter diameter jet having a velocity 30 meter per second strikes a flat plate, normal of which is inclined at 45 degree to the axis of the jet. So this is a problem based on the inclined plate. So you are asked to find out the normal pressure on the plate. Normal pressure means it is the Fn value only, force exerted in the normal direction. So and also the power and efficiency. So as you can see, the diameter is given, so you can find the area. So here angle between the jet and the plate, theta. So here you have given an angle, the normal of which is inclined at 45 degree to the axis of the jet. So the normal of the jet is inclined at 45 degree to the axis of the jet. So the actual angle between the jet and the plate will be theta is equal to 90 degree minus 45, or it is again 45 degree. Now velocity is 30 meter per second. So again plate is stationary. You will find out the Fn, substitute the value. You will get the answer as 2810.96 Newton. Now the plate, when the plate is stationary, you have the value like this. When the plate is moving with velocity v minus velocity 15 meter per second, you have to consider moving plate case and substitute, and the expression changes like this: rho a into v minus u the whole square. Here it was v square, here it is v minus u the whole square into sine theta. Solve one more problem of a curved plate case. So a jet of water diameter 7.5 centimeters strikes a curved plate at its center with a velocity 20 meter per second. The curved plate is moving with velocity 8 meter per second. The jet is deflected through an angle of 165 degree. Assume the plate is to be smooth. Find force exerted, power and efficiency. So writing the given things: diameter, finding the area. Area will be in meter square, and the velocity of the jet is given capital V, velocity of the plate U, and how you are given the jet is deflected through an angle of 165 degree. So angle of deflection is given 165 degree. How to find out theta from that? So theta will be 180 degree minus the angle of deflection. 180 degree minus the angle of deflection, that is angle of deflection here it is given by 165 degree. So that is mentioned here. So the angle made by the jet and the plate is given by theta into theta is equal to 180 minus 165, that is 15 degree. So the theta is not directly given here. This is the angle of deflection. So how to find out theta from that? It is just 180 degree minus 165 degree. You'll get theta as 15 degree. And again substituting the expression for a curved plate, you will get fx is equal to rho a into v minus u the whole square into 1 plus cos theta. Substituting the value, you will get the answer like 1250.38 Newton. So the second part of the problem, again work done is fx into u. You'll get the value like this, and the power is nothing but divided by 1010 kilowatt. And efficiency of the jet, the third part of the question, it is output by input. So proceeding in the similar way, you will get finally the value of efficiency as 56.4%. So in all these problems, you just have to remember the expressions related in each cases, and accordingly do the substitution and find the answer.